Tool wear. Productivity and economy of manufacturing by machining are significantly affected by life of the cutting tools. Cutting tools may fail by brittle fracture, plastic deformation, or gradual wear. Turning carbide inserts having enough strength, toughness, and hot hardness generally fail by gradual wears. With the progress of machining, the tools attain crater wear at the rack surface and flank wear at the clearance surfaces, as schematically shown in the following figure. Next slide. Due to continuous interaction and rubbing with the chips and the work surfaces respectively. Among the aforesaid wears, the principal flank wear is the most important because it raises the cutting forces and the related problems. Features of wear of turning tool. There are some pictures. Section AA, then auxiliary flank, principal flank, and rack surface. VV means average flank wear. VN means flank notch wear. VM means maximum flank wear. VS means average auxiliary flank wear. VSM means maximum auxiliary flank wear. KT means crater depth. KM means distance from center of crater, and KV means crater width. Features of wear of turning tool. The life of the tools, which ultimately fail by systematic gradual wear, is generally assessed, at least for R&D work, by the average value of the principal flank wear, that means VB, which aggravates cutting forces and the temperature and may induce vibration with progress of machining. The pattern extent of wear of the auxiliary flank, that means VS, affects surface finish and dimensional accuracy of the machined parts. However, tool rejection criteria for finishing operation are employed in this investigation. The values established in according with ISO standard 3685 for tool life testing. A cutting tool was rejected and further machining stopped based on one or a combination of rejection criteria. First one is average flank wear greater than equal to 0.3 mm. Second one, maximum flank wear greater than equal to 0.4 mm. Third one, nose wear greater than or equal to 0.3 mm. Fourth one, notching at the depth of cut line greater than or equal to 0.6 mm. Fifth one, average surface roughness value greater than or equal to 1.6 micrometer. And sixth one or last one is excessive chipping, flanking, or catastrophic fracture of cutting edge. Mechanism of tool wear. In general, there are 7 basic types of wear that affect a cutting tool. Abrasion. Mechanical wearing. Hard particles in workpiece removes small portions of the tool that cause flank and crater wear. This is the dominant cause of flank wear. Adhesion. Two metals contact under high pressure and temperature that cause welding between the materials. Diffusion. Atoms on the boundary of workpiece and tool changes place. This is the principal cause for crater wear. Chemical reactions. The high temperatures and clean surfaces at the chip tool interface in machining at high speeds can result in chemical reactions. In particular, oxidation on the rake surface of the tool. The oxidized layer, being softer than the parent tool material, is sheared away, exposing new material to sustain the reaction process. Plastic deformation. Cutting forces acting on the cutting edge at high temperature cause the edge to deform plastically. This causes flank wear. Cutting tool materials properties. A good type of tool material should possess certain desired properties such as: number 1, the material must remain harder than the work material at elevated operating temperature. Number 2, the material must withstand excessive wear even though the relative hardness of the toolwork materials changes. Number 3, the frictional coefficient at the chip tool interface must remain low for minimum wear and reasonable surface finish. Number 4, the material must be sufficiently tough to withstand the shocks of intermittent cutting. If not, reinforcement must be provided. Number 5, the tool material should also possess high thermal conductivity for quickly removing heat from the chip tool interface, have a low coefficient of thermal expansion, not be distorted after heat treatment, be easy to regrind and also easy to weld to the tool holder.